See the next topic. Factors on which the resistance of a conductor depends. Means which type of materials the type material can be have a some quantities. So on that quantities then the different factors will be there. So on such factors we have to depends on the conductor. It means the resistance of the conductor depends on its length of the material, on its area cross section of the material, and on nature of the material. So these are the three main important role in these factors on which the resistance of a conductor depends. So that's why length, area and nature. Length, area and nature. So the resistance of a uniform metallic conductor is directly proportional to its length. So the resistance is directly proportional to the length of the material. So R is proportional to L. That is the first equation. See the second one. The resistance of a uniform metallic conductor is inversely proportional to the area of cross section. That means R proportional to 1 by A. So length is directly proportional and area is inversely proportional of the resistance. So from these two equations we get, from 1 and 2 we get R proportional to L by A. R proportional to L by A. Hence R is equals to rho L by A. This is rho. What this is? Rho. Hence rho. Here rho is a constant proportionality and it is also called as electrical resistivity of material. So rho is a constant proportionality. That means rho is always constant. So some types of some given constants can be such type of materials also. That means resistivity of the material. So which has as good conductors or bad conductors. That means it is also a electrical resistivity of the material. So the SI unit of resistivity is ohm meter. Ohm meter. See, R is equals to rho L by A. L means L the units can be called as meters and area can be units as meters square. What is it? Meters square. So then rho is equals to RA by L. R means ohm, A means meter square by meter. Meter can be cancelled. Then the remaining term is ohm meter. So that's why the SI unit of resistivity is ohm meter. See the materials. The metals and alloys have very low resistivity. The metals and alloys have very low resistivity. Its range is 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. So it is a good conductors of electricity. Good conductors of electricity. Some example: silver, copper, iron, manganese, tungsten. So like that material. So this type of material can be called as good conductor. That means a low resistivity, very low resistivity materials. So this range is 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. So that means 1 into 10 to the power of 8, 2 into 10 to the power of 8, 1.16 into 10 to the power of 8, like that. So 10 to the power of minus 8 means. So see here the insulators. The insulators means which has no conductivity of the material. So how much current is can be going on through this, but current is not absorbing. That means insulators. The insulators like rubber and glass have very high resistivity. Very high resistivity. When rubber always could not be taken as any current, and glass also could not be taken as any current. So that's why the insulators are should be like as rubber and glass. It has very high resistivity. Its range is 10 to the power of 12 to 10 to the power of 17 ohm meter. That means 2 into 10, 1 into 10, 3 into 10, 4 into 10, like that. So the power of 10 is 12 to 17. 12 to 17, that means 10 to the power of 12 to 10 to the power of 17 ohm meter. It is a bad conductors of electricity. It is a bad conductors of electricity. See some notes here. Alloys. Alloys means metals. Metals and alloys do not oxide. So how much current can be absorbed? It is burning, but it is not dispose of any material. That means it's a rapid very high temperatures. So for this reason, we are commonly used in electrical heating devices like electrical iron toasters and the bulb, the electrical bulb is a filament will be there. That filament can be made by tungsten. So that's why tungsten is one of the alloy and one of the metal. So tungsten is used almost exclusively for filaments of electric bulbs, and copper and aluminum wires it has a generally used for electrical transmission lines from power stations. So we know about this thing. Some examples here. See, you have to do in your homework this example. How much current will an electric bulb drawn from a 220 volts source? If the resistance of the bulb filament is 1200 ohms, then how much current will an electric heater coil drawn from a 220 volt source if the resistance of the heater coil is 100 ohms? In this problem, we have identified two sources will be there, two voltage sources. One is 220 volts of the filament and another one is 220 volts of the heater coil. But given the resistance of electric bulb filament is 1200 ohms and resistance of the heater coil is 100 ohms. Hence, we find the two different type of currents here. One of the electric filament current, that means bulb filament current, and second one is heater coil current. So you have to find in your homework.